Now we want to talk about how write propagation is ensured, and then we want to talk a little bit about memory consistency models. In a directory-based protocol, it says, write propagation is achieved through invalidation. What that means is that when one processor writes data that another processor was using, then it has to invalidate the data that the other processor was using. And if the other processor ever reads that data again, it suffers a cache miss and then has to refetch the data. And when it refetches the data, it's the up-to-date data that the other processor read in. No matter how many other processors wrote in the interim, the data that it fetches will always be the up-to-date data. Multiple writes to a block are serialized by the protocol. The transaction, as we have seen, closes after an ACK from the current owner is received by the home, and it doesn't entertain another write request, another readx request, until the previous readx request is closed. So things are being serialized here. One transaction needs to finish before the next will be processed. This provides write serialization. So here's a diagram of serializing writes by A, B, and C. So you see here that A does its write, and there the ACK is received, and then B proceeds, it does its write, ACK is received, and then C proceeds. Now, I wonder if you can tell me, just from the diagram, whether this is using the home-centric or requester-assisted approach. Okay, it's using the requester-assisted approach, and we can see that because this flush does not have to finish before the next transaction can go ahead. So it's not waiting for everything to happen, it's just waiting for the ACK to be received by the home, and then the home can conclude the transaction and go on to do something else. Now let's talk a little bit about memory consistency models. When implementing sequential consistency, all memory accesses by a processor need to be issued and completed in program order. Now that says issued and completed in program order. Which of the two is harder to assure, issued in program order or completed in program order? Well, yes, that's right. It's completing in program order because when it issues, well, that only has to happen in one place, the processor. When it completes, it has to be the case that anywhere in the system, or I should say everywhere in the system, the effect of that transaction, that read or write operation, are seen. Actually, write is what we're concerned about because read completion is just really easy. Read completion only has to be seen in one place. When the processor that's doing the read fetches the data from the cache, then the read has effectively completed. And prefetching and load speculation can be used. In other words, the read can appear to take place before it actually does, and if it guesses it reads the wrong value, then it just needs to go and redo the operation and read the correct value. So we talked a little bit about speculation earlier, but I just want you to note right now that prefetching and load speculation are consistent with the requester-assisted approach. But as the average number of processors grows, the average latency of a cache miss increases just because it can go out farther in the network or farther in to the far reaches of the multiprocessor. So it can take longer, and that means it's harder to hide it. So when memory operations take longer, and all memory operations to share data need to be serialized throughout the entire system, it just becomes less viable, and so sequential consistency becomes just unachievable as your system gets really large.